Hey guys, this is Manak and today we'll be designing a G+2 building in STAAD.Pro Connect Edition. And before starting this, if you want to know some configurations which you do in STAAD, we'll also do that. You can see these are the coordinates which you can see for a building, and these coordinates was marked using the normal coordinate system in STAAD.Pro. Now I'm just going to show you how to configure stat file to begin with, so that your units are in the proper place. So this is the opening window which you see, and you can simply go here and set your units to metric, and then you can do changes to these codes, IS codes, and also if you want to change the color of your windows also you can do this here. So these are some basic things which you can do. It's preferable not to change the axis because by default instead Y stays up, so if you change that, a lot of other things have to be changed, so better not change that. So go to new and we'll just do this by equivalent static method. We know that this building is in zone 5, and if you follow the rules of the code, then it should be designed by response vector method. But first of all, we're going to design this by equivalent static method, and also maybe in the later videos by response vector method, when we can compare the results as well, to what extent the difference comes when we use the two separate methods. So first of all, we're going to insert the coordinates. So if you want to have a separate video on how to prepare these coordinates, I'll make that. You can request in the comment section. So simply the axis, you can see Z is up and X is in the right side. So by using this, I have marked all the main points or the main beams or the junctions between the main beams and the columns, and Excel is a useful way by which you can do this. In MS Excel you can easily mark the coordinates. Make sure that I always prefer to keep the plinth level as 0 and take the foundation negative. Okay, so the Y height or the plinth level is taken as 0. The next floor height, if it's 3 meters, then 3. And the foundation depth, suppose it will be 2 meters, then it will be minus 2.1, like this. So you can simply just mark the coordinates in Excel along with the nodes, and then you can easily copy and paste in the STAAD.Pro. So that's what you can do. So I've just copied here all the coordinates, as you can see. I also have to insert the node number as well here. Okay, so some coordinates, all the main beam coordinates are copied, and I will paste it in Excel itself just to insert the node number here starting from 1, and then we can drag it and get the remaining coordinates. So once we do that, we'll just copy, go to stat and click on this one here and Ctrl plus V, and then click on OK. So you can see in the isometric view that these nodes are present. Just have to join this node with the help of add beam command. So we are joining these nodes here one by one. So first of all, joining this horizontal nodes and then vertical. So in more complicated structure, you have to do a little bit more carefully and always follow a simple order, because otherwise it's possible that you might forget a node or two. So it's very important that you follow this, especially if there are secondary beams also. Here all the beams are primary beams. So the node cursor, I'll select all the nodes here, and I'll give a foundation depth of minus 2.1 meter. That is the foundation depth plus the plinth height. I'm taking as 2.1 meters since it's the bottom direction, the downward direction, so it is minus 2.1. So I'm clicking on OK here, and then link steps also has to be turned on. Okay, so we can go to the front view and simply select the topmost portion. We'll do go to geometry and do a translation repeat, and the floor height is 3 meters, and we'll also just click on link step this time. Okay, and we'll do only one step because in the next step we want to add some portions of the balcony. So I'm going to click on OK here, and you can see this floor has been added, and just select this floor and click on new view, because in this view for this level I'll just add the balcony portion. So I'll simply add the balcony portion using coordinates, so you can see what is the last marked coordinate here, and you can see the side portions can be neglected because they are very small 0.6. The front balcony I'll provide. The side balconies won't be any difference anyway. So the front balcony I'll provide, and the coordinates I'll just write in Excel and then copy to the STAAD, and then I'll join the beams. So that is my strategy for this. So let me just open Excel and I'll just write the coordinates for this. And these 3 coordinates I copy, and this is the from here. Here I had copied a wrong coordinate, so it should be written 0 actually, so I'll realize it later. So I just correct the marking or the node number, and then I copy, and then I'll paste it here. You can paste it here, click on OK. You can see the one coordinate which I placed wrong, so I just have to change the coordinate X to 0, and then it will be OK. So we'll do that. We'll just change the coordinate to 0 here, and you can see it will just if you just click out, then it will it should come back to the right place. So it has come back to the right place. Now we can just add beams here, and then we can add these beams as well for the cantilever. So this portion has been done. Now we can go to the full view or the display whole structure, and the structure is properly displayed now. Then we can go to the front view and select this portion, and we can use translational repeat here. It's better to use translation repeat along with the for the 2 floor at once. So I'll do that. So I used link steps. I shouldn't have used link step because I already selecting the entire floor here. I can see the entire floor has been selected now, yeah, like this. And now I'll use the translation repeat without link steps because I don't need that. I've already selected the columns as well. So step 2, and this is complete. Now you can see the structure has been completed here, and then we move on to the properties and we add the properties. So initial size which we're giving for the columns is 0.3 into 0.3, and for the beams also we'll provide this is for the plain beams. Let's provide the size. Click on add, and then for the roof beams, the final size for the roof beams, please note the ZD and YD values. These the last values is for the second value in the bottom is for the width, and the top value is for the depth. Okay, now we go to select and assign the values for the columns, and the properties for the beams can be set by the front view, and we can just set the properties of the beams from here. So plain beam property is set. Now let's use control to select multiple beams, multiple levels of beams you can say, and then click on yes, and then the other things are automatically assigned, so you can directly move on to the supports and just assign the supports. Obviously we take the fixed supports into consideration, and we'll just create and assign the supports. You can see in the isometric view supports as well. So move on to the loading. First of all, let's define the SysPic mass source, which will use the STAAD editor, but you can just select the latest IS code and then click on generate, and then we know all the things, zone 5, and then special moment resisting frame, medium soil, damping ratio is 5%. As you know, anything you want a detailed video on, please ask in the comment section, or some things which you can tell in the comments as well, I'll tell it. And then we move on to the next thing. It's foundation depth. I'm just entering this foundation depth, and then we move on to the next thing, which I've already told in my several videos. So we'll move on to the clause here, and we'll insert these in the X and Y direction as well. So I'm just opening the file here, and we'll open the portion where we have it. So as you can see, the building height can be 3 meters floor height, so it is 9, and if you take the plinth height as 0.4, so it's 9.4. so let's keep this as such. And then the x and y can be easily seen from our plan. There is a picture of the plan which we have, and you can see approximately x distance can be taken as 11, and y distance can be approximately taken as 10.5x, and y distance can be approximately 14.5. so we'll just insert these values here, 10.5 and 14.5, and calculate the values of this TA in the x and the y direction, or instead there will be x and z. So let's just do this. Calculate. I'm just using the calculator to calculate this, and we'll just write the value here, 0.09 into 9.4 into root over 10.5, this is 0.26, and the next value, I'm just calculating this, and then it is 0.25, 0.22. so this is the value, and then we'll just go to STAAD.Pro, insert this value, and click on generate. So this is pretty much stuff. And if you have the STAAD editor, if you use the STAAD editor, you can just directly enter this, no need to create this step as well. You can directly use copy and paste from the text file. I'll also use create a video shortcut video for this. Okay, so let's define the primary load codes. So now we'll define the dead load, and dead load will keep in seismic load. Seismic load will be our first load, SLX, and then it will be seismic load in the Z direction, that is SLZ. So we're taking lateral directions into consideration here. And then that the seismic load in the X direction, and then also in the Z direction in seismic load we'll add one seismic load in Z direction as well. And then let's add this, and let's just add the dead load here, and third number will be dead load DL, and fourth number will be our live load, or LL. Okay, LL entered. Then we'll enter the dead load components. First of all, obviously self weight, since it is acting from top to bottom, it will be minus direction. And this floor load, or the load of the walls, you can easily calculate. So I'll open my calculator and calculate that. First, open that calculator here. First of all, we have the 3 meter at the height, 0.125 is the thickness of the wall, and 20 is the unit weight of, approximate unit weight of brick wall and concrete cement mortar put together. So this is this value, and we can also add the floor finish load of minus 0.5. Most of the tiles and marbles are covered in this. And in the dead load, I also have to add the slab, which I had forgotten here actually, but I add later in the STAAD editor. You can see that. So remaining things in live load, since it is also a flow load, you can add in the STAAD editor. So you can go quickly move on to the STAAD editor itself. You can see the live load has automatically been assigned. Self weight you can assign to view, and for the wall load, you can just first of all, I'll apply in the plinth level, because in plinth all the beams have this load. I'll just select beams and just apply that, and then for the above portions, sparing the terrace, I'll select the two floors except the terrace, because the terrace will not have these walls. You can add parapet wall load if you can, but I not add it here. So just select this, and not this actually, I want to select both of them except the terrace portion. Okay, so you don't need to select the terrace portion like I'm doing now. I only need to select the two floors. Okay, so let's go. First selection, second selection, and then right click and then click on new view, and then click on OK, and then we go. We selected this, and then we can apply it on all the portion except the balcony. As you can see in the plan as you earlier, that only the balcony portions have the walls. So that's it. So this is done, and then we go and apply the live load in the STAAD editor, or the command file which you call in the connect series. Earlier it is called STAAD editor. So you can easily zoom in using the mouse wheel and control button. You can zoom in and below. And first of all, let's add the live load here in the flow load portion. I have copied wrongly, so I will again we'll just select this and we'll copy this, paste this here. Residential building live load 2 is sufficient, so we'll go with 2 here as the live load. Now for in the seismic mass source, that is we add the complete dead load, 1 into dead load and a portion of the live load. So I'm just copying the dead load here first of all, and later we'll realize that I haven't put the so I haven't put the slab weight. Okay, so I'm just we'll just insert this dead load here, and as we know, minus sign or the negative sign and y or any direction we have to remove, and the member load will be member weight, floor load will be floor weight. So this is just a shortcut for nothing. You can insert in the model itself. Then the static data we do, this is just a shortcut. The direction and signs just have to be removed here. So the seismic mass for the dead load has been done, and for the live load there will be a percentage. So since the live load is 2, so it is less than 3 here, so 0.25% will be taken. So it was more than 3, then 0.5% would be taken. Okay, so that's the case here. Now I'll in this point we have realized that I have not added the load for okay, this portion I am just adding the live load percentage. So live load is 2, so that's why this 0.5 is added. This is a percentage of the live load. 0.25 into 2, that is 0.5. so the live load has been added in the seismic mass. And in the dead load, as we had forgotten to add the slab weight, we'll add the slab weight in dead load first, and then we'll also include it in the seismic mass source. So if you considered a slab thickness of 0.15 mm, then 0.15 into 25 should give you the dead load. So we'll just calculate the value here, 0.15 into 25, and this value we can insert as floor loads in both the dead load part and also the part of the seismic mass. So we can do that easily. Let's complete this step here, and you don't even need this, because for the dead loads they can come under a single wing. You can easily understand that. So only STAAD gives you this liberty of using the STAAD editor, and there are a lot of tricks by which you can check syntax, and there are a lot of tricks by which you can see. So I'm just going to add the load combination here, a file which you can download from the description. Okay, and you can just copy this part, and these are all the load combinations, and you can just simply paste it in the STAAD editor file. I don't need to create them one by one always. You can just copy and paste them here. So copy this portion, and load envelope is useful for the post processing results, which includes all the load combination in here. So simply just paste it here after the live load, simply paste it, and you can check syntax once again. And once you're sure that all the syntax are properly done, then you can easily just save, plus Ctrl plus S to save any changes, and then close the command file. Okay, or the STAAD editor file as you earlier called it. And then you can simply go to analysis and add the analysis command here. Click on all, because we just need to, if you need to check other things, just click on all, add, and then we can run the analysis here first. And after first we'll run the analysis and then we'll design, because we just going to check whether there is any error in the process. Because once you click on design, because then all the failed members will also show as warnings. Okay, so now you can see there are no errors here. Now we can just go to design. So by default our design is selected in IS code. Now automatically you can see when you press concrete, IS456 appears. So the minimum parameters which you have to give is clear cover and the composite strength of concrete and composite the yield stress of reinforcement. Okay, FCK and FY which you have to provide. So just select this. Other things are really not necessary, because anyway we are not following the detailing for fully. So these are the minimum things which you need. Let's give cover 40 for all, as it doesn't affect columns. Okay, and composite string will take M25 for all the structures, and let's go with Fe500 steel, which is now Fe550, Fe600 is also available in the market, but let's go with 500 here, and click on add here, and then we have to assign this. So we'll just assign them, assign to view, everything will be assigned to view here, and then we'll have to add the command, then the results will come. But let's again check the analysis, whether the analysis is okay. And so you can see, just to show you, okay, you can see the analysis results. Now also there are no, you can see the warnings, okay, the design is not done, but there are less warnings as well. Okay, so now if you add, let's add the commands here, design beam and design column, and then select the beam and select column. The reason I am doing this, because just to show you that when the members fail, or then it shows up as warnings. So you need to check the warnings here after you just assign and apply the design beam and design columns. Okay, so just run the analysis here, and when the analysis is run, you can see the warning number has increased. So if the warning number has increased, it means that some members, you can see that the warnings, let me just click again. Sometimes we can see the reinforcement exceeds the limit, means the member have, you can see, yeah, the members have failed. Reinforcement exceeds the maximum limit when members have failed. Some members have failed. Okay, now you can see the reinforcement here also. So the members which have failed, we can pass them. So the best option of detailing here is the RCDC, which is the advanced concrete design, and it's a product of this Bentley package RCDC, and it's very compatible. But for the initial checks, you can just see in the STAAD file itself. Later on stages, the RCDC is the best solution, and saves a lot of time actually if you use this. So what you're going to do, you can just check all the beams and column result here by clicking here one by one. All the members which are failed, they will not show the concrete design. Okay, the members which passed will show the concrete design. You can see it here. And for the final results, for exporting the results also, RCDC is the most viable option as per my opinion. And those of you who watch my videos, you know that. So let's design the columns here in RCDC, and then we'll go for maybe the foundation, and then we'll go for the roof beams. So we'll get an idea, and also I'll tell my friend that whether you can continue this building up to G+3 or not, because he has already constructed the ground floor, and he wants to know that whether it's safe to construct the top floors above it. So I'll just give the suggestion based on the results here. But okay, simply you can just give any new names and details. So first of all, let's go with the columns. Let's see what are the columns files, because in RCDC we'll apply the ductile detailing. So in the ductile detailing, let's see what are the members which are passing. So first of all, we'll go to, you can see the level data, and you can, this is the best way you can change the grade of strength of concrete and steel here, FCK and FY, and also the cover, we'll change that. And once you change one, you can just copy and you can select them and paste it in the other columns or rows or cells, sorry, forgive me. And then you can save the project using Ctrl+S, and then you can just edit some things. I'll just click on the ductile design and click on OK, and then you can design the columns here. And then this will be the seismic loads, this is the live dead load, and the next one is the live load. We'll just select all of them and proceed, and then we'll just add from analysis option, because already we have click on add from analysis here, already we had, and then you can run the design here. So we can see the members are failing, and whichever members are failing, they can be passed here like this. Click on design, and then you can just change the size, and then you can deal with it. Okay, so the bottom part has failed. So let's just increase the portion of the bottom portion to 400 maybe, and let's see. okay, this is the reinforcement coming, this is pretty decent. And now you have to do this and repeat this for all the columns which have failed. Okay, so I'll do a little bit of fast forward in here. So as you can see, the columns have been marked safe now, all of the columns here, and these are the sizes. You can just save the project once again before exporting the results. The main result which you need is the column layout and the column schedule. So first we're going to go with the schedule, and we're going to save the file here, tactile schedule, and we're going to save the file here, and then we're going to save the layout. Okay, see the results here. Save this in my location for this particular client and name it, and then save this. Similarly, I'll save the column layout as well. I have yet marked the schedule as layout, so we can change it later. So this is the, you can just change it to layout, sorry, schedule, and this one will be layout, which you are right now saving. So once this is saved, we can go to our STAAD file once again, and this time we'll click on RCDC once again, advanced concrete design, and this time we'll go for the beam design. Beam level at 0 is the plinth level and 3 is the roof level, so we'll go with the roof level portion and see what is the design which is coming here. And we'll select beam first of all, and once you select beam, we'll select the level as 3, which is the roof slab, and then we'll do the required settings here. So ductile setting, obviously this will be priority. M25 and MP500 will be a priority, and also a reinforcement also you can do up to 25 mm if you want, that is preferred, 25 mm reinforcement. And then we'll just select this and give the name here, seismic load in X and Z, and then we'll go with dead and live. Select all these, same step will be repeated. Add from analysis, click on OK, and design, and I think we'll get a pretty reasonable design. Yeah, we got a pretty reasonable design. You can see all the loops are passed, and also you could take the reinforcement, whether they are practically applicable or not, they are okay. So we can export the results after saving the file. So we'll press Ctrl+S to save the results here. So anyway, if you have made these up to this in the video, just drop a heart in the comment section, just to keep encouragement to make more videos for you. And any topic if you want, just comment below. I'll try to make the video for you. First of all, let's save the schedule of our roof beam. So we'll name this as roof beam schedule, and also we'll need the roof beam layout as well. So if you want to see my drawing video, I'll also give the link in the description, or you can ask me in the comments if I don't give just for the drawing video, how to make the drawings for this. So using this RCDC results, I make the drawings here conveniently. Okay, after saving this, then we have to go for the foundation. So now for the design of foundation, you always need the soil test report here, and we have the soil test report here, and the soil is favorable for pile design. So pile capacity is already been calculated in the soil test report. We just have to know what are the number of piles. So select pile cap and click on enter. And if you know that by as per the latest code we have to provide at least minimum 3 piles under each column, but here I'm going to take the liberty and just go with 2 here, but this is wrong. As per the code you have to provide minimum 3 piles below each column for the stability, otherwise the structure is not considered as stable. But for this let's do it 2 here just to show you, and then we'll insert the diameter here from the soil test report. Okay, so you can see the soil test report here, and we'll choose the pile diameter of 500 mm and insert all the parameters here. So this is in turn, we'll just multiply in 10 to convert into kilonewton. Ideally we should multiply by 9.81, but approximately we multiply by 10, okay, just to convert this into kilonewton from ton. And the rest of the process is pretty easy, and just it will calculate the number of piles for you and also generate the drawing. So the user friendliness of this software is good, but only one demerit of this is that you cannot go for matte design here or also for combined footing design here. For that you need STAAD Foundation Advanced or some other package like SAFE from the. So that's one disadvantage. If I find a way around with that, I'll also make a video, and if you know that, you also know that just click on OK, and the remaining steps are similar here. Just need to set this to pile diameter here, and ideally if you work for any project, always click on minimum 3 because that is the code requirement. I'm again and again telling you this because otherwise you'll say that I've not told you. Okay, so then the remaining steps are same, just for we have to import the column data, that is better, so the column sizes and the marks of the columns will be updated from that, and also the loads of the self-weight will be more, so self-weight will be updated here. So that's an important thing which you can do here. Import the column data. As you can see, the column size have increased. Now we can go for the design. You can add the same process: seismic load in X direction, seismic load in Z direction, dead load, and then live load, and then we move forward with the load combination, add from analysis, and the sizing combination we'll just add from template for regular structure. Sizing combination, click on OK, and then we design, or we'll set for design, and we'll just click on design, and then design will be done for the pile caps here. As you can see readily, 2 pile and 3 pile combinations, but ideally we should have gone for the 3 pile in all the pile caps, regardless of whether it is exceeding or minimum, or not exceeding the capacity. Okay, so that's the thing, and then you can save the file, and you then save the project, the pile layout and pile cap layout and pile cap schedule. You can save that, and that's how design a project, and you can use this file for your design and referable structural drawing formats, so that you can be easily seen that. So you have to put a lot of work in preparing your format and preparing this file so that they're easily executable in the site, but having a software like RCDC which exports the results makes them useful. So that's all for today. Thanks for the love and support, guys. Bye bye. Keep learning.